Now we're going to talk about digital to analog conversion. In the previous case, we were doing analog to digital conversion, the idea being that you had a sensor that you were trying to measure from and you needed to get that information into the hapkitboard. Now we have the other direction. Now we know some output that we want to give in terms of an analog signal, and we have to figure out what is the digital signal to command in the hapkit code in order to generate that analog signal. And typically, the reason why we want to do this is because we want to create an output on our actuator. So if we have a motor and we would like it to apply a certain amount of force or torque, then we need to figure out what is the digital command to send out that will result in that force or torque. So in this case, you're doing a D to A conversion going from bits to volts, although you don't really have to write it in bits. Just remember that it's really in bits, but it's going to be written in a decimal number. All right, one problem that we have with hapkits, and in fact all Arduino boards in general, is it doesn't have any true A to D converter. It's important that you know that D to A converters exist, because they do on some types of boards. But since there isn't a real D to A converter, we're going to be using PWM, or pulse width modulation, instead. And this idea was already introduced, but let's go over it in more detail now. So the process here is that in your code, this is now in your software, so I'm going to emphasize that. This is in code. You're going to figure out what is the force you want to compute, what is the force you want to output as a PWM duty cycle. And we'll review those terms in just a minute. But this is code that you're going to write. If you, say, have a haptic virtual environment and you want the motor to put out a certain number of newtons, or have the user feel a certain number of newtons as they hold on to the handle of the hapkit, you're going to need to use the information that you have about the kinematics of the device in order to figure out what output you want to command. And then the next step is to convert that duty cycle to a decimal value between 0 and 225. And this is interesting. This is only 8 bits of information, actually. We had 4 bits in the example a few slides ago, but now we have 255, so this whole thing is really 256 different pieces of information, and that corresponds to 2 to the 8th, so it's 8 bits. So our resolution in D to A is not as high as our resolution in A to D. So remember, that one was 1024. And this is actually very common for A to D versus D to A. On a lot of different mechatronic systems that you'll encounter, the analog to digital resolution is higher than the digital to analog resolution. All right, so in your code, you have to actually use a function in order to write that output. Once you've computed that decimal value representing a resolution of 8 bits, you have to use a function, in this case analog write, where now you specify both the pin number and the value that you want to output. And the value has to be in these numbers between 0 and 255. So the pin must be a special PWM pin on the hapkit, and just like the Arduino, and you can look this up for any Arduino board, there's a certain set of pins which can do these sorts of PWM outputs. And in our code, we use pin 5, which is one of the pins that can do it. So let's look more at PWM so that you can get a good feeling for how this is working in this context. So let's re-examine PWM in the context of being able to give a digital to analog signal. So in these pictures here, it's showing different levels of duty cycle, that is the proportion of on time to the total period of a digital signal. And remember, we're replacing what would be a conventional D to A conversion with a pulse width modulation, where the idea is that the average signal is going to be constant. So here's some examples of the average signals that you would get on these plots. So because this is on only 10% of the time, then the average signal is going to be 10% of the value of the voltage. In this case, you could say it's between 0 and 5 volts, so 10% of that. 50%, of course, it gets higher, and 90%, it gets almost to the top. And if the switching is fast enough, remember that it's not going to seem to your hap kit, it's not going to seem to your motor as if things are switching on and off. It's just on average going to be assumed to have this constant value. So the result is that it's like an analog signal. So it's as if you've done a D to A conversion, but instead you're using pulse width modulation.